In this section, we're going to be looking at fossils. Like we said earlier, or in other sections, fossils are preserved remains of organisms that lived in the past. Preserved remains such as bones and teeth, or impressions such as footprints. Otherwise, we can define fossils in different ways. For example, here are remains of ancient life forms preserved in rock. Okay. They may occur also either in ice, tar, and dried sap of trees. For example, amber. Okay. Amber. That's dried sap of trees. Paleontology is the study of fossils, and hence those who study fossils are then called paleontologists. Paleontologists. Okay. How do fossils then form? Formation of fossils. Of all sources of fossils, the richest are found in sedimentary rocks, rocks that sediment, or rocks that are formed as a result of sediments. Now, sands and silts are washed, some minerals or materials that are washed from the land and carried to the seas and swamps by rivers, because rivers flow into seas and flows into swamps and carry materials, particles such as sand and silt into these huge water bodies. When organisms die, their remains will settle at one point. Even if they were floating, their remains will settle at the bottom of these water bodies like the swamps or the seas. The mineral salts that are found inside soil particles will also settle at the bottom of the seas, for example. And with time, these mineral salts will then infiltrate. They will filter, go inside the body of these dead organisms, and they form a kind of mold around that body, such that the organism becomes petrified, meaning that the organism will be turned into stone. And when it turns into stone, it will hardly ever decay again. It will become preserved, so that even after millions of years, we can come and find it, and we'll call it then a fossil, because it's from ancient times. Okay, in my definition of fossils, I always said two things in two parts: preserved remains and or impressions. So fossils could be the preserved remains. It means we'll rather find maybe the actual organism itself or parts of that actual organism, maybe because the other parts have decayed away. Otherwise, we could also find impressions, which are imprints that are left when an organism has already decayed before it could even become petrified. It means that with some organisms or with some fossils that have formed over time, the organism itself has already decayed, but before it decayed, salts had surely accumulated on the external parts of this organism, such that it forms a kind of mold or cast. And within that mold, the organism completely decayed because it was maybe too late. But then the markings, the outlines of the outside structure of that organism will be left in that cast, will be left in the stone. And it is these markings, or it is these outlines that will be preserved, and that will refer to us at that point as fossils, impressions. Now, when sedimentary rocks form, they pile up over each other. You can see here, they've piled up such that they formed layers. And each of these layers is referred to as strata for plural, or the layers are referred to as strata, otherwise stratum. such that the oldest layer is at the bottom. It means this one is older than this one, which is older than this one, which is older than this, which is older, and the youngest layers are at the top. Now, when we look at the different strata, they could be seen as have been successfully formed within a particular period of time. Remember, a period, okay. The period could be a subsection of an era. So within a particular period, we had that species evolving and also getting extinct, or some species evolve in one period and get extinct in another period. And since this strata form during periods, it means that when a species dies, when a particular organism dies, it could become embedded, it could become submerged by sediments to form sedimentary rock, buried within that sedimentary rock, such that if we dig the sedimentary rock, we will find certain fossils in some layers of the sedimentary rock, suggesting that these fossils were formed at that particular period. It means if I find a particular fossil here, it means that it formed at that period, which will be different from the period at which another fossil here would have formed, different from another period at which another fossil in this other layer or stratum would have formed. Index fossils. Index fossils will then give us an indication of the time period, the period within the era in which these fossils were formed. And index fossils are good to use because they have a wide geographic distribution. It means that they are found not only at one place, but they are found in a large number of places and can be used then to estimate the time at different geographical areas where these fossils would have formed, such that we can have kind of an aggregation of timing when these fossils are formed. Okay, some examples of fossils. As we know them, we were categorizing them in terms of hard parts like bones and teeth, for example, or impressions like imprints. Okay, so examples will include bones of vertebrates. These are organisms like mammals, like you and I. Could include shells, like the shells of snails, or the shells of bivalves that we mentioned in another slide earlier, or the exoskeletons of invertebrates. Invertebrates include organisms like insects. For example, they have an outer skeleton, that's why they hide on the outside. Or we could have impressions in the form of tracks, otherwise footprints in the form of burrows, traces that are left, markings that are left when organisms dig holes, could become fossils. Burrows of, for example, earthworms, or hardened physics, excretion of animals that lived in the past could be as well regarded as fossils. Other examples could include petrified trees, which have deposits of minerals embedded into them so that become kind of stone, or imprints of leaves that left their traces on surfaces. Those imprints could be fossils or imprints of small animals. Fossils could also occur in tar or asphalt, the material that's used in making our roads, or frozen in ice. For example, the fossils of the woolly mammoth, the huge elephant with very long fur, were usually found frozen in ice. And fossils of the saber-toothed cat, like the saber-toothed tiger, were found in pits of tar. The saber-toothed tiger and the woolly mammoth are also present in that famous cartoon, Ice Age. So we find them there. I'm sure you guys know by now what they look like. While some insects, like mosquitoes, have been found in amber And amber is the hardened form of liquid sap, the liquid that comes out from plants, that whitish liquid. When it hardens, it becomes amber. And if organisms are trapped in there, then they can get fossilized because they won't decay again over thousands of years. It's possible to fossilize it that way. Usually we would have to determine, or usually we have fossils and we are also given alongside the age of these fossils. But the question is, were we present at those moments such that we can be able to determine what age these fossils actually have? Methods have then been developed. So far there are 2 of them that have been developed so that they can be used to determine the age of the various fossils that are found in different excavation sites in the world. These include relative dating and radiometric dating that we are going to explore. In relative dating, the age of the fossil is not very much exact. It's just an estimate. So this estimate is done or is worked out by comparing the current fossil with another fossil or a geological event which occurred at a certain period within an era. It means then that, for example, I could have 2 fossils, A and B. I already know the age of fossil A, but I don't know the age of fossil B, but I can work out in relation to fossil A, that's relativity, in relation to fossil A, that of which I already know the age, I can work out from that point the age of fossil B. Or I can work out the age of fossil B based on an estimated time or period when a particular geological event occurred, such that I could know, for example, if my geological event, for example, is a volcanic eruption, okay, I could say, for example, I could find out the age or the period at which this volcanic eruption occurred, and I know that it's either my fossil B, of which age I don't know, either formed before that volcanic eruption or after the volcanic eruption. Let's say the volcanic eruption occurred around 2000 BC. It means if my fossil formed somewhere before 2000 BC, then I would say it formed maybe around 2001 BC. That would be before. Or if it formed after 2000 BC, then I will say it formed around 1999 BC. That is after. It means the ages are even getting smaller and smaller until we get to that BC, the end of BC. Okay, so we determine the age of a particular fossil in relation to something. That's relative dating. Okay, remember during different periods, different layers of rock, of sediments are piled up to form strata or stratum. So we have a consistent arrangement or layering of these sediments. And remember again, we said earlier that within each layer, we could find fossils in every layer. And if a fossil is found in this particular layer, it means that it was surely formed within the period when that layer was formed. It then means if that natural arrangement is kept undisturbed, the layering is not disorganized or mixed up such that we have a top layer or a mix up with the bottom layer. If everything is kept intact, then we can always determine or tell the age of a fossil, for example, in a lower layer, since it would have formed before the fossil that is found in the upper layer. So it would clearly mean that if I find in an undisturbed area where the layers are still fine and in their natural order, if I find a fossil in a lower layer, by implication, since the lower layer is older than the upper layer, by implication, the fossil in the lower layer would be older than the fossil in the upper layer. For example, say the fossil in the upper layer was my A, and I know the age of A. By implication, the fossil in the lower layer would be much older than the fossil A, of which age I already know. But relative dating, like we said, it does not tell us the exact age of the fossil. It's just a very broad estimate. Okay. So if the original layering, if that original order of layers is disturbed, if everything is mixed up, then we can easily compare the layers. And means also we can easily compare the age of the layers. We can compare the age of the fossils to one another. This becomes very difficult for scientists to establish the age of fossils that they would want to establish by using relative dating. Another attempt then that scientists would rather do would be to use index fossils, because index fossils, like we said, occur in many geographical areas. If one area has the layers disordered, another area might have the layers still intact in the correct order. We find an index fossil in that other area or in another area, then we estimate the age in that area, and by implication it means the age of the fossil found in the disturbed area would be the same as the exact same kind of fossil found in another area, because it's being used as an index fossil. If, say, for example, we have the presence of a new fossil and an index fossil found together at the uppermost layer, that's the top layer of rock, that it means that scientists from this information can then conclusively say that the rock actually came from a lower layer. It means there was solely a mixture whereby the new fossil must have come from the lower layer, and due to geological events, the layering was upset and mixed up such that the new fossil came up all the way from the bottom to mix up with an index fossil found at the top layer. So that's why we're saying that the original layer was upset by a geological event, and the result of this would be that the new fossil was formed before the other fossil. It means the new fossil which was found at the top layer with the index fossil was actually an old fossil that had formed long time ago before the index fossil, and that fossil that came up to be with the index fossil was supposed to be at a very, very low layer in the bottom, not at the top. It means there was some kind of mixture.